Today we're going to talk about Kirchhoff's laws. Kirchhoff's laws are used to solve complicated circuits with two or more power sources. So we know that there are two Kirchhoff's laws. Kirchhoff's current law, which states that current flowing towards a junction is equal to current leaving a junction. Or sometimes they usually say current entering the node is equal to current leaving a node. We're going to explain this on the later stage. So law number 2 is Kirchhoff's voltage law, which states that the algebraic sum of the voltages in a closed loop must be equal to 0. As you can see on the picture, the algebraic sum of the voltage in this closed loop gives us 0. You can see V1 plus V2 minus E2 gives us what? 0. So let's go to an example. So to explain Kirchhoff's current law, KCL, is it states that the current entering the loop is equal to the current that is leaving the loop. So this current that is entering the loop is going to split into I1 and I2. When this current reaches this point, it's split to I1 and to I2. And when it reaches this point, it's going to come together to make IT again. That means the current entering the loop is equal to the current that is leaving the loop. Now, Kirchhoff's voltage law. Kirchhoff's voltage law states that the algebraic sum of the voltages in a closed loop must be equal to 0. So that can be explained using this simple circuit. So the algebraic sum means that the voltages that we have in this closed loop must give us 0. So this voltage plus this voltage and this voltage and this voltage must give us a total of 0. So we know that Vt is equal to V1 plus V2 plus V3. If we take this one, we're going to have 0 is equal to V1 plus V2 plus V3 minus Vt. And this one gave us what? 0. So to understand this, let's go straight to one example. Now we're going to look at this simple example. So on this example, they are asking us to calculate the current that is going to pass through the 10 ohm resistor. So to do that, we have to name our current and name our loops as well. So we can say this is going to be A, B, C, D, E, F. And the current that is flowing here, we're going to say it's I1. And the current that is going to be flowing in this side is going to be I2. So from here, we know that current is going to flow from positive to negative, and also on this source from positive to negative. So current is going to be flowing towards what? The 10 ohm resistor. And then the current that is going to be passing here is going to be your I1 plus your I2. So some other textbooks just say I3, but if we are saying I1 plus I2, it's actually going to simplify our problem solving. Okay, so now on this example, we have 3 loops. We have this loop here, which is going to be A, B, E, F, A. And then we have this loop here is going to be B, C, D, E, B. And we're going to have the loop that is going to be outside of our circuit, A, B, C, D, E, F, A. So we're going to choose 2 loops to make 2 equations. So consider loop A, B, C, D, E, F, A. So when we move from A to C, we are going to look for any voltage drop that we are going to get. Remember that Kirchhoff's voltage law says the algebraic sum of the voltages in a closed loop must be equal to 0. So we are looking for any voltage drop that we are going to get across the loop that we have chose. So when we go from A to B, there is no voltage drop. But when we go from C to D, we're going to get a voltage here, which is going to be 20 volts. And we're going to take the sign that we came across first. It's going to be the sign of our what? Of our voltage here. And then we are also going to have a voltage drop here across this resistor. So since we are moving from A, B, C, and D, that means here we are going to be moving in this direction. And then our current here is going to be moving in an opposite direction. So if the current is moving to the opposite direction, then the sign is going to be minus. And the voltage drop that we are going to get here is going to be 2I2. Please note what I've explained here. And then we're going to move to D, F, and there is no voltage drop here. And then from F to A, we're going to get a voltage drop here. So the voltage drop here, since we are moving this direction, and then the current here is also moving in our direction. Therefore, it's going to be plus. It's going to be plus 4I1. And then if we continue, we're also going to get a voltage here. The sign that we are going to take is going to be the sign that we come across first, which is this one. Therefore, it's going to be minus 10. It's equal to 0. So now we are just going to simplify. So to simplify, we're going to take, we have 4I1, which is positive, minus 2I2. And then we're going to have 20 minus 10, we're going to have plus 10 is equal to 0. And then minus 2I2, we take this 10 to the other side, it's going to be minus 10. This is equation 1. Okay, so now we're going to take another loop. So we can take any loop. So let's say we are taking A, B, E, F, A. So considering loop, we're gonna consider loop A, B, E, F, A. So now when you consider loop A, B, F, A, so from A to B, there is no voltage drop. But when you go from B to E, there is a voltage drop here. The voltage drop here is going to be 10 times I1 plus I2. Therefore, we're going to put it there. 10 I1 plus I2. And then from EF, there is nothing. Then from FA, we're going to have a voltage drop here, which is going to be plus, since the current is still going in our direction. So it's going to be 4I1. And then we're going to have a voltage here, and we're going to take the sign of the voltage. Then it's going to be minus 10, it's equal to 0. And then we are going to simplify. If we are simplifying, it's going to be 10 I1 plus 10 I2 plus 4 I1 minus 10 is equal to 0. Okay, so now when we are simplifying, we're going to have I1 and I1, 10 and 4. That's going to give us 14 I1 plus 10 I2 minus 10 is equal to 0. And then we simplify it further. I1 plus 10 I2, we take this to the other side. We are going to have positive 10. This is going to be equation 2. So now that we have made equation 2, we can take either equation 1 or equation 2 to make equation 3. So if I take equation 1, then I'm going to substitute equation 1 in equation 2. If I take equation 2, I'm just going to substitute it on equation 1. So now let's take equation 2. So equation 2 is 14 I1 plus 10 I2 is equal to 10. Then I'm going to make I2 subject of the formula. Then I'm going to be left with 10 I2 is equal to 10. Okay, now that we have, this is going to be our equation 3. So now we're going to substitute 3 into 1. So I'm going to write I1, equation 1, since it doesn't appear here. Our equation 1 is 4I2 minus 2I2 is equal to minus 10. So now where we see I2, we are going to substitute with 1 minus 1.4. So we are going to have 4I1 minus 2, 1 minus 1.4, so 4I1 is equal to minus 10. So we're gonna have 4I1 is equal to 2, and then 2 times 1.4 gives us, and negative times negative is going to be positive 2.8. I1 equal to minus 10. Now we're gonna simplify that. It's going to give us 6.8 I1. We take this to the other side, it's going to be positive. Then we are gonna have minus 10 plus 2, which is going to be 6.8 I1 is equal to minus 8. Then we divide 6.8, divide 6.8. Therefore, I1 is equal to 8 divided by 6.8 is equal to 1.176 amps. This is I1. And then to get I2, we're just going to substitute this on equation 3, because equation 3 is just I2. Then shortly our I2 is going to be sub I1 in equation 3. Then this is equation 3. Then it's going to be 1 minus 1.4, and I1 is 1.176 to get I2. And it's going to be 1 minus 1.4, 1.176. This will give us minus 0.646 amps. And then our IL, which is the current that is going to be passing here. Remember, we have established that the current that is passing through the 10 ohm resistor is going to be I1 plus I2. Then IL is going to be I1 plus I2, which is equal to our I1 is 1.176 plus our I2 is minus 0.646. This gives us, calculate 1.176 minus 0.646 gives us 0.53 amps. So this concludes our problem to solve using Kirchhoff's law. So I'm going to use some other examples. Just check the link in the bio for other examples, and please don't forget to subscribe. Thank you.